Hi friends, welcome back. Today we are going to create this infrastructure on AWS. So basically we are going to create virtual private cloud on AWS that's called AWS VPC along with two public subnet 1 and public subnet 2, two private subnet 1 and private subnet 2, and two data subnet 1 and data subnet 2, along with a route table for these respective subnets and internet gateway for public subnet where a resource in public subnet can be reached from internet. We are also going to create NAT gateway for private subnet where a resource from private subnet if needs to download some package, some data from internet. So it download from there through NAT gateway and a data subnet. We can use NAT gateway in case we need to download some data from internet, but I assume our data subnet will be for RDS and I'm not expecting anything to be downloaded from internet. So it will have default VPC uh, routings, so it's able to communicate this all remaining public and private subnets. So this complete infra we are going to create with Cloudformation template, and for that I have set of Cloudformation templates we are going to use. So this is the readme and I'm going to use this master.yml, and then we are going to use vpc.yml, and also we will be using app cloud app1.json. So I will be talking each by I'm going to talk each files line by line, and we understand what are purpose of these different files, and also we understand uh, cloud formation template syntax along with all resource what we are going to create. And for that we are going to use AWS CLI, and for me AWS CLI is configured here. So from console we can see AWS S3 LS. So we can see I'm able to list all S3 buckets from my AWS account, and we have only one S3 bucket. So that's good. So let's start from a readme. So I have a readme here where I have described of how we are going to bootstrap this infra. So first of all, we need to create S3 bucket. Why do we need to create a S3 bucket for creating a VPC? Basically, I am using a nested stack, and when we use nested stack, so a stack for child stack, we need to pass template. So I'm going to upload a child stack template in S3 bucket. For that, we need to create S3 bucket. So to create S3 bucket, first of all, I'm going to export S3 bucket name, and that will use in subsequent commands. So export bucket, and let's make this bucket name cloud advisory, and we exported. Now to create S3 bucket, we will be running this command AWS S3 MB make bucket and S3. Then we are going to pass S3 bucket variable, the variable which we exported with the name cloud advisory. We can see here a make bucket executed, and it's created cloud advisory bucket for us. To make sure this bucket is got created, let's go to the AWS account. So this is my AWS account and I'm in the Frankfurt region. So let's navigate to S3 dashboard, and here we see, so we have seen one S3 bucket was there, that was elastic bean stack in EU Central 1 region, and we have created this bucket cloud advisory, and it don't have any data. Now let's go to the readme, and here as I said, to create child stack we need to upload child stack template to S3 bucket. To do that, I'm going to use again AWS CLI command, AWS S3, and I'm going to sync my local directory to S3 and the bucket. So bucket what we have created just now, and in infra folder. So it's going to also create infra folder, and there it's going to place all my local directory files. So I'm going to execute this from this infra folder from my local system. And also I want to exclude all git folder files because that's really not needed for me. So to do that, we are going to copy this command and we will run from our terminal. So we see here it's uploaded a readme file, cloud app1.json, cloud app2.json. I will talk about this JSON file why I have here, then vpc.yml and master.yml. And as we see, it's uploaded from my local folder to S3, and this is the bucket name, cloud advisory what we created, and in infra folder and this file. And if we do ls here, so we can see all these 5 files, 1 2 3 4 5. So we have all these files has been uploaded to S3. Now to bootstrap this infra creation, we have this again AWS CLI command line for the Cloudformation. So we'll be using AWS Cloudformation create a stack and a stack name. So a stack name, I will be going to use cloud app1, and template body we are passing master.yml. So let's look at this master.yml what we have, and now also we are passing this parameter files. So parameters, let me change it to cloud app 1.json, and we really do not need any IAM capability because I'm not going to create any IAM roles and policy, so we do not need it. Then I'm passing tag, just we really do not need tag here, but I'm passing for sake of understanding, and the key is name and the value is cloud advisory. So first of all, let's understand these parameters. So here we have a cloud app.json. Cloud app.json, here we have some parameters that we are passing. So first parameter is S3 artifact store, and this is nothing but bucket what we have created. So this is artifact for our nested stack where we are put all our template. So this is cloud advisory. Now we are also passing as a parameter VPC CIDR range, and this could be any public IP range. So for me, I have used a 10.33.0.0/16, and then I'm passing private subnet 1 CIDR, sorry, public subnet 1 CIDR, then public subnet 2 CIDR, again for private subnet 1, private subnet 2, data subnet 1, data subnet 2, and I'm using subnetting 24, so we'll be getting around 256 IP. Some IP used to reserved by AWS, so almost we'll have the 251 IP addresses. Okay, so here I have created this JSON file for parameter, and we really do not need it. We also, what we can do, we can pass these parameters instead of file, we can pass here as a parameter key and value. So if you want to know how do we do that, so let's copy this and check from the browser. If we come here and search this, so let's open the first link, and here see this is documentation to create a stack. And if you scroll down, we have the example here. So here as a parameter, either we can pass as a file, so what I'm doing here as a file, or we can pass individual parameter here. So here we can see first parameter key is key pair and its value is the test key. So similar, if I don't want to use file, then I can pass like this. But just for simplicity, and we are going to use it for the different purpose, I'm going to tell you what would be the different purpose. So that's why I created this file. Now let's look at master.yml, what this file contain. Let's save this. Master.yml. In master.yml, we have a AWS template format version, then a small description, this to create a infra, and then we have parameter. So we need to capture all the parameters what we are passing from our parameter file. So all this parameter need to be captured here. So I'm capturing a S3 artifact store, then VPC CIDR, then all this parameter. Then in resource section, I'm creating VPC stack. So to create VPC stack, type need to be AWS Cloudformation and stack. And in property, we need to pass template URL. So as we uploaded this file in our artifact store, so let's go and have a look. Let's close it. Now here in cloud advisory, that is our artifact store. If you open, okay, let's sorry, so okay, so we have uploaded that, and we see we have the infra folder, and now we have vpc.yml. So, and this is the complete link. So if you see here, this is the object URL, this is the link that what I am using here. So here we are using https and this s3 and bucket name, then we have infra folder and vpc.yml, and this template needs some parameter, and that parameter we are passing here, and these parameters we are taking few parameters from here, not all, whatever parameters we need in VPC template. So we need VPC CIDR, public subnet 1 CIDR, public subnet 2 CIDR, like that. And in output section, we are getting internet gateway details, VPC details, public subnet 1, public subnet 2 ID, private subnet 1 ID, private subnet 2 ID, and so on. Now, so that's pretty much in master template. Now let's look to the VPC template. In VPC template, first we need to capture all these parameter. So here see, as usual, we have AWS template format version, then a small description where I have written we are going to deploy VPC with pair of public and private and data subnet, and that's spread across two ability zone. So this is high available architecture, and it's also deploying internet gateway and NAT gateway. So you see we pass all these parameters. Now we are capturing all these parameter here in parameter section, and in resource section we will be creating our infra resources. So first we are creating VPC. To create VPC, we need the type need to be AWS EC2 VPC, and in property section we are passing CIDR block range. So that is nothing but VPC CIDR, and as we get this from the parameter in parameter, so we are referring it here, and we are also enabling DNS support and DNS host name, and instance tenancy is going to be default, and also we are using name tag. So uh, it will create it will name VPC with a stack name, and it's also append VPC. If you don't pass it, so it don't come with any name, so we need to pass it, won't come with any name, so that's why I'm passing this tag. Okay, so other questions come here. How do we understand what will be the property and how this looks like? So to understand this, if we copy this type and we go to the our browser, and let's type this, and let's open first link, and here we see this whole documentation to create AWS VPC resource. And here in syntax we have JSON format and YML format. As you see, I'm using YML format. So let's look at the YML format. So here we see we are using same. We used type and all these properties. So this is the reference where we will come back and check what we need to be included when we will be creating AWS resources. So it's not necessary to use all these properties. If you don't use, so default one will comes, and if you don't want default one, then we need to change it. So here only few properties are here, but when we create other resource, then it comes with the bunch of the properties, and we really do not need all. And if we need something, then we can customize it as per our need. If you look at let me give you another example. So transit gateway, I think it's a very simple one. VPN connections could have more. Yeah, you see here. So here it comes with the a lot of properties, so that need to be defined. Now let's come back here. So this is syntax for the VPC. Now I'm creating internet gateway. So for internet gateway, type will be AWS EC2 internet gateway. In property, again I am passing a name tag to name it, and then we are attaching our internet gateway to VPC. So this is to VPC gateway attach, and we are passing internet gateway ID. So this is our internet gateway ID. So you see it's we are getting from here, we are referring to internet gateway, and now VPC, and the VPC we got from, we also create VPC here. Okay, so here if we see, so these three resource are related to each other. So first we created is create VPC, then internet gateway, then is attach internet gateway to VPC. So here a Cloudformation engine is very smart, and it's understand which resource need to be created first. So accordingly it will create a resource. It's not go and try to attach a internet gateway with VPC, because VPC is not there and even internet gateway is not there. So what it will do, it will first create VPC, then it will create internet gateway, then it will attach. So that's how a cloud formation engine execute. Apart from this, sometimes we know dependencies, so we can also manage dependencies. So for that, what we can do, we need to write depends on. So once we do depends on, then we can type internet gateway. So what it will do, it will first create internet gateway, then it will create VPC, then it will execute this resource. But anyways, we really do not need it because it's very simple one, and cloud formation engine really understand this. Now going forward, here we are creating a public route table. So to create, we need type should be AWS EC2 route table. Then we are passing VPC ID and tags. Then we are creating public subnet route table, and here in route table we are, as we see here, type is EC2 route and it depends on internet gateway. So before creating public subnet route table, it will first create internet gateway to internet, then it will create a public subnet route resource. And in properties, we are using route table IDs and destination CIDR block and gateway ID. Now we are creating a public subnet, then we are associating a public subnet route table, then we are creating a public subnet 2, so pretty much same code, and then we are creating private subnet NAT gateway. So to create NAT gateway, first of all we need elastic IP. So we are creating a elastic IP here. Then we are creating a NAT gateway. Then we are creating a private subnet 1, and we have all this related code here. So first we need to create a subnet, a private subnet. Then we also creating route table for private subnet 1, then we're creating root, and then we are associating private subnet with the route table. So this code is here, and same we are doing for private subnet 2. So pretty much same code. And then we are creating a data subnet. So it's pretty much same code. So you see here we are creating a subnet, then we need VPC ID, availability zone. And one thing here we see, when we are selecting availability zone, then we are using select, and then we are using get agent function. So if you really don't understand meaning of any of these functions, so we need to copy, and when you go to the browser and we type here, and let's make AWS. So we will, when we open first link, then we see this is basically conditional function. So what this function will do, it will return all availability zone in the respective, in the current region, and from them we are selecting first 0 key. So it's return array of availability zone, and out of them we are selecting 0 index. So it's creating, and if you see our data subnet 2, then we are selecting here 2 1. So first data subnet will be created in AZ1, and second will be created in AZ2. So 0 index and 1 index. And same we have done for the private subnet as well. If you see here, private subnet 2 is in subnet 1 and this in 0. And then we are creating RDS subnet groups. So for that we need subnet IDs. So we are using subnet ID 1 and subnet ID 2. And of course, finally we will be extracting and getting all a resource created. So internet gateways, VPC ID, public subnets, public subnet 1 ID, public subnet 2 IDs, and all this information. So that's a pretty much from the cloud formation side. Now let's go and create the stack. So to bootstrap this in infra, we will use this command, and let's go to the console. Let it clear. And so AWS cloud formation, create a stack, then a stack name, and master.yml parameter is cloud app1.json, and the key and value. Okay, so we see it started creating a stack, and we got this stack ID. So let's copy it. We need it when in AWS cloud formation console, when we have so many, maybe hundreds of stacks, so it's good to copy from here, and we can go search there. And also we can search by name, but in my case I don't have much, so we can easily able to see our stack. So we see here it's creating a stack name cloud app 1. So let's go to our console, sorry, AWS CLI, and we see our stack name is cloud app 1. So this is cloud app 1, and this is the description we can see from here. Let's click this one, and here this is the stack ID. So see, this is the stack ID, and again you can see a description, status, it's creating, so creation time, and some more metadata is here. And we use a tag name, so we can see tag here. We don't have any stack policy, we don't have any rollback configuration, we don't have any notification options, so nothing much here. And we come to event, and event we can see it's started creating cloud app 1 logical ID, and then it started creating VPC stack, and VPC stack creation is in progress. And we cannot see anything here as created, is still in progress. So what is in a resource, what is supposed to create, is supposed to create only VPC stack, and that we can confirm from our cloud formation template. So here we see in the resource we are creating only VPC stack, so that's why we are seeing here our resource as VPC stack. And all information related to here, if we go to here, or we can come directly from here. So here, come to here, you can see all this stack information, all events. So here we see so many events because we have so many resources here. In the resources we have VPC, internet gateway, and so on and so on. So we would see all these resources here. So we see all this event has been started. Okay, it's started creating internet gateway, then VPC, then we see internet gateway got created, VPC got created, and then it started creating remaining resources, and few of them is completed. And we refresh from here, so looks like VPC stack completely got created. So if we come to in resource tab, then we see all these resources has been created for us. So either we can navigate from here, so if we click here, so it will redirect us to on VPC console, or we can go from here as well. and we can see all this information here. So we have all is got created. Let's this stack to be completed. So yeah, so also we see, so it's got created. Then we also see final status from the event. So VPC stack got created and cloud app one stack also got created. So everything is ready. Now we can go to VPC console, and here we can see we have one VPC, we have 6 subnets, we have 4 route table, one internet gateway, and so on. Let's go to the VPC. In VPC we have see all VPC details. So this is VPC ID, and this is available. This is VPC CIDR what we have used, and this is property we have enabled, route table, tenancy is default, so on. Come to the subnet, we see we have a public subnet 1, public subnet 2, private subnet 1, private subnet. Okay, so I think I have some done mistakes. So one need to be private subnet 2, so it's saying both are private subnet 1, so I need to change it. Then a data subnet 1 and data subnet 2, but again I have some typo here, so that need to be changed. And the route table and internet gateway. So we see as we have automated our infra creation with Cloudformation templates, so how easily it's get created for us. Now let's understand what is beauty of this automation. So we have seen we have created all this infra for the cloud app 1, and let's say we want to create same infra for the another application, maybe cloud app 2. So what we need to do for that, as our automation is pretty much ready, so we don't have to do much work. Only what we will do, let's close all this, and here we need to create another parameter file. So I have created cloud app2.json, and I copied all these parameters from here and pasted here, and I have done small changes. So here S3 artifact store need to be changed, cloud advisory. Okay, so here's two things. If we are creating another application cloud app 2 in same account, so we do not need to use another S3 artifact. If you want, of course we can use it, but in that case it's really not needed. But if we are creating in another AWS account, in that case that need to be recreated with the new name. And for CIDR, I have changed CIDR for all these parameters. So for cloud app 1 I was using this 33, but for cloud app 2 this is a 10.22. So same I have done here, and that's all. Now we have to do nothing. Only what we do, we need to copy this command, and here Cloudformation kit, let's change this stack name to a cloud app 2, and master stack will be same. And now our parameters file need to be changed, and tag, if you want to change we can change, if not it's fine. And once we run this command, it's going to create whole set of infrastructure for our cloud app 2. So it's going to create another new VPC and 6 subnet. to public subnet, to private subnet, to data subnets. Also, it will create a new internet gateway for the app 2 VPC, and also NAT gateway for app 2 VPC private subnets. And here you see we have really done nothing, just we changed our parameters and we spin up whole infrastructure. Now let's go back to the AWS console, and in Cloudformation dashboard, if we refresh here stacks, and we see we have another set of stack. Cloud app 2 is getting created, and it's also creating cloud app 2 VPC stack. So let's wait for a few minutes and we will see uh, it will create all these resources, but meantime we can see few resources here. Yeah, so as we can see, we have another VPC called app 2, cloud app 2. If we come to the subnet, we could see 12 subnet now, so we can see one of 12. So if we filter here, we see cloud app 2, public subnet 1, 2, then so on. So we see here we have two public subnet for cloud app 2, two private subnet for cloud app 2, two data subnet for cloud app 2. Then again we have for cloud app 1. If you go to routes table, we would have additional four more route tables, and we have one more internet gateway for cloud app 2, and so on. So I hope it's completed now. No, it's creating. So friends, what we have seen, when we have automation in place, how easily we can use our code to automate and create infrastructure again in very short span of time and very easily. So that's all from this video, and thanks for watching.